الرحمن الرحيم.
Solve the given initial value problem. We have the quantity x squared plus 2y squared times dx dy equals xy, where y of -1 is equal to 1. So at first glance, this equation appears that it possibly could be separable, but we're not able to do it directly. But we can notice that this can possibly involve functions that are homogeneous. So x squared plus 2y squared, if we consider that some function f of x comma y, if we find f of tx comma ty, that will be t squared x squared plus 2t squared y squared, and that will be t squared times the quantity x squared plus 2y squared, which is equal to t squared times f of x comma y. So that function is homogeneous. And the function on the other side, the xy, we could call that some function g of x and y. And g of tx comma ty, that will wind up being t squared times xy, which is the same as t squared times g of x comma y. And so since these are homogeneous, we can try to use substitution. So the substitution that's generally recommended is that y is equal to ux. So we'll substitute that into the equation. And if we use this substitution, we should note that dy, well, that's going to become u times dx plus x times du. So now we'll substitute everything into our original equation. So on the left-hand side, we'll get x squared plus 2, and then the y, of course, is going to become ux, and we'll square that. Then we'll multiply by dx over, well, now the dy is going to become u dx plus x du. And that will be equal to x times y, which is now ux. So we're going to wind up with x squared plus 2u squared x squared, that quantity, then times dx, and that will all be over u dx plus x du, and that will be equal to then u times x squared. And then we can multiply both sides by u dx plus x du. When we do that, we'll wind up with the quantity x squared plus 2u squared x squared times dx equals, and when we multiply by distributing, ux squared times u dx will be u squared x squared dx, and ux squared times x du, that will be ux cubed du. So this is the equation that we have, and now we'll try to simplify this a bit. So we'll first try to distribute. So we'll first distribute on the left-hand side, and that will give us x squared times dx, plus we have the 2u squared x squared times dx, and on the right-hand side we have u squared x squared dx plus ux cubed du. And if we subtract everything on the right-hand side from both sides, so we'll subtract this quantity from both sides, we'll wind up with x squared dx plus 2u squared x squared dx minus u squared x squared dx, and then we'll subtract ux cubed du, and that will be equal to 0. And we can note that these two terms with the u squareds, x squareds, will be like terms, so we can subtract, and we'll get x squared dx plus u squared x squared dx, and then we'll subtract ux cubed du, and that will be equal to 0. And then we can factor out an x squared here. So when we factor out an x squared, we're going to get x squared multiplied by 1 plus u squared dx, and then we'll subtract ux cubed du. And of course that will be equal to 0. So now we're getting closer to being able to use separation of variables. we can now add the ux cubed du to both sides, giving us x squared times 1 plus u squared dx equal to ux cubed times du. So we have du on the right and dx on the left, so we'll want all the x terms on the left and the u terms on the right. So we'll divide on the right-hand side by the x cubed, so we'll have to do that on the left-hand side. And on the left-hand side, we'll divide out the 1 plus u squared, so we'll also do that on the right-hand side. And this will give us the following. So the 1 plus u squareds will cancel on the right-hand side, and we'll get 1 over x dx equals, and on the right-hand side, the x cubes cancel, and we get u over 1 plus u squared du. And now we can integrate both sides because we've separated the variables. So when we integrate 1 over x with respect to x, of course, we'll simply get the natural logarithm of the absolute value of x. And when we integrate u over 1 plus u squared, it seems that we'll get the natural logarithm of 1 plus u squared. But of course, the derivative of u squared is 2u. We only have a u here, so we'll need to multiply that by 1/2, and then we'll add a constant of integration, c. And to get rid of fractions, we can multiply both sides of this equation by 2, and that will give us 2 times the natural logarithm of the absolute value of x equal to the natural logarithm of 1 plus u squared plus, well, we're going to get 2c. We'll let that be equal to some constant c sub 0, so we'll have a c sub 0. So that 2 times the natural logarithm of x, of course, that will be the natural logarithm of the square of the absolute value of x, but that's going to be the same as the natural logarithm of x squared. So x squared is the same as the absolute value of x and then squared. And that will be equal to the natural logarithm of 1 plus u squared plus this c sub 0. And then we can subtract the natural logarithm of 1 plus u squared from both sides, giving us the natural logarithm of x squared minus the natural logarithm of 1 plus u squared equal to c sub 0. And then using our rules for logarithms, we can write this difference of logarithms as the natural logarithm of the quotient, x squared over 1 plus u squared. And that will be equal to c sub 0. And then what we can do is we can note that this is a base e logarithm. So this x squared over 1 plus u squared, that's simply going to be e to the c sub 0, or c naught. And what we can do is we can let e to the c sub 0 be equal to some constant c sub 1. So we'll get x squared over 1 plus u squared equal to c sub 1. But this would be our solution, but we should note that we had used the substitution y equals ux. So in this case, u will be y over x. So now we'll need to reverse the substitution. So we'll get x squared over 1 plus, well, the square of y over x is y squared over x squared, and that will be equal to c sub 1. And to simplify, we'll multiply both the numerator and denominator of the left-hand side by x squared. And that will give us x to the 4th over x squared plus y squared, and that will be equal to c sub 1. Or we can multiply both sides by x squared plus y squared, telling us that x to the 4th will be equal to c sub 1 times the quantity x squared plus y squared. So we have this general solution, x to the 4th equals c sub 1 times x squared y squared, but we have an initial value problem. We're told that y of negative 1 is equal to 1. That tells us when x is equal to negative 1, y is equal to 1. So we'll substitute those into our equation. So x to the 4th will become 1, and that will be equal to c sub 1 times, well, x squared will be 1, as well as y squared. So we'll get 1 equals c sub 1 times 2, and dividing both sides by 2, we'll wind up with c sub 1 equal to 1/2. So now we can substitute that into our general equation, giving us x to the 4th equals 1/2 times the quantity x squared plus y squared, and if we wish we can multiply both sides by 2, giving us 2x to the fourth equals x squared plus y squared. And so for this given initial value problem, we were able to use a substitution. We used the substitution y equals ux to get an equation that was in the form of something separable, and then we used separation of variables to get this general solution. X to the fourth equals c sub 1 times x squared plus y squared, and then we were able to use the given condition in order to solve for c sub 1, ultimately getting this solution 2x to the fourth equals x squared plus y squared.